Hi, Math 30s. We're moving on to lesson 7, which is called double angle identities. And just like in lesson 6, I'm going to solve the class examples in the workbook, but I'm also going to introduce some new examples. Those extra examples can be found in a PDF on the Google Classroom. Okay, so what makes a double angle identity? The reason why it's called double angle identities is if you look at the argument for each of these angles, each angle is doubled. So that would be called a double angle identity. Now, what I want you to notice is for the double angle identities, so for sine, there's one form for sine. For cosine, there's 3 forms for cosine having a double angle. So cosine tends to be sort of the trickiest that you're going to be dealing with. And then tan, there's one form for the double angle of tan. Let's start looking at double angle identities by proving an identity. So the proof that we're going to do is this proof here. 1 plus the sine 2 theta is equal to sine of theta plus cos of theta squared. Okay, so what are we going to do here? I'm just going to put my equal sign here. This you're going to recognize as a double angle. Sine of 2 theta is a double angle, which would be this identity here, right? And sine is nice and easy because we only have one identity that I could replace this with. So I'm going to bring that 1 down and put plus, and then sine of 2 theta, I'm going to replace it with its identity, which is 2 sine of theta cos of theta. Okay, if you look at the right-hand side, what we have on the right-hand side is a binomial squared. How we're going to deal with this is we're going to write each binomial twice because it's squared. And then we are going to end up using the distributive property or FOIL to get rid of our brackets. So if you use a distributive property, what you're going to have is sine times sine is going to be the sine squared of theta. Sine of theta times cos of theta would be sine of theta cos of theta. And then you'd have the same thing, sine of theta cos of theta. So that gives you 2 sine of theta cos of theta plus cos of theta times cos of theta is cos squared theta. Okay, so this looks sort of like a bit of a mess, but what you need to see here is a couple of things. This matches with this, right? So I'm not going to deal with 2 sine theta cos theta because that's actually matching over here. What I need to look at is I need to look at this sine squared theta plus cos squared theta. That is an identity that you did back in lesson 4 and 5. That identity is a Pythagorean identity. And the identity was if you have the sine squared of theta plus the cos squared of theta, it is equal to 1. So if I have sine squared of theta plus cos squared of theta, I could replace that with its identity, which is going to be 1. And then that would be plus 2 sine of theta cos of theta, which is exactly what I have on my left-hand side. So because I have the exact same thing, left-hand side is equal to right-hand side, I have proven my identity. The next class example I want to do is going to be from your lesson. So it's on page 642, and we're going to prove this identity, and then we're going to state the non-permissible values. So I'm going to look at the sine of 2x again. Sine of 2x is your double angle identity, and what the sine of 2 theta or 2x could be rewritten as is the identity for that. So sine of 2x can be rewritten as 2 times the sine of x cos of x. Okay, now let's look at the right-hand side, or sorry, the left-hand side. I've got 2 tan of x. So 2 tan of x. We know that tan of x is sine of x over cos of x. And that is going to be divided by 1 plus tan squared of x. Now, one of the tricks, remember, is if you have a 1 and then plus or minus, and you have something squared, look on your formula sheet and see if you could replace that with a Pythagorean identity. And this can, in fact, be replaced with a Pythagorean identity. So if you look at your formula sheet, 1 plus the tan squared of x, that is the same thing. The identity for that is the secant squared of x. So I have 2 tan of x divided by, I'm going to replace this with its identity, which is the secant squared of x. Okay, from this step, I'm going to keep this. I can't really do anything here. So 2 sine of x over cos of x divided by, replace this with the identity for secant squared of x. So what's the identity for secant squared of x? That is 1 over cos squared of x. Okay, so now what I'm going to do, instead of dividing, I'm going to multiply by the reciprocal. So I have 2 sine of x over cos of x. And I'm going to multiply that by the reciprocal, which would be cos squared of x all over 1. What we could cancel is I have a cos of x with a cos of x, and I'm left with 2 sine of x, cos of x. And if you look, that is exactly what I have on the right-hand side. So I've just proven my identity because left-hand side is equal to right-hand side, and my proof would be done. Let's do one more proof together, and this is going to be from my own note package. And the reason why I want to do this one is because it's going to deal with the cos 2 of theta, and remember that there's 3 different options that we could choose from. So I'm going to actually start on the left-hand side, negative cotan of theta. So we know that the cotan of theta is the cos of theta all over the cos of theta over the sine of theta. Okay, I can't do anything else on the right-hand side, so now I'm going to go to the left-hand side. This I recognize as a double angle identity, sine 2 of theta, which would be this identity right here. If I replace it, I'm going to replace it with 2 sine of theta cos of theta. That is all over cos of 2 theta minus 1. So this is another double angle that I want to replace with its identity, but I actually have 3 to choose from. What's interesting is you could actually choose either of these 3, and you're just going to be manipulating, changing things around, and you would get the same answer. So you could pick any of these. I'll just pick this one. So I'm going to replace the cos of 2 theta with its identity, which is this guy here. So that would be 1 minus 2 sine squared of theta. And then I need to bring down this minus 1. What you need to notice now is in this denominator, I have 1 minus 1, which cancels. That just becomes 0. So rewriting this, I have the 2 sine of theta, cos of theta in my numerator, and I have negative 2 sine squared theta. A sine of theta is going to be canceled with the sine of theta. And sorry, 2 is going to cancel with 2. I still have that negative, so I'm going to bring that negative down. And I've got a cos of theta in my numerator and a sine of theta remaining in my denominator. And if you look, the left-hand side now equals the right-hand side. So I have finished my proof. So left-hand side equals right-hand side. And the proof is complete. Okay, this identity proving this identity. This is a really good example. I just don't want to take too much time in this video to go through it. So this is a podcast that you could watch this video being solved, and it's podcast lesson 14C. Let's go on to class example 2. Okay, what's happening in class example 2 is it's giving us the identity for the sign of the double identity for sign, right? So it was giving us this identity here. And what it's saying is it wants us to use this identity for the sign of 6x, okay? And they want me to write the sign of 6x as a double angle identity using the identity for sign of, the double angle identity for sign. Okay, so what does this mean? They want me to write the sign of 6x in terms of the double angle identity. So what I need to do is, if you look at the double angle identity, it's always the sign of 2. So this can be rewritten as the sign of 2. And then I need to figure out what my angle is. So if I divide 6 by 2, I'm going to get 3x. Okay, and now what I've created is I've created what my angle is. So alpha would be this, because to make a double angle identity, it has to be sine 2 of alpha. And now I've rewritten the sine of 6x as the double angle, sine 2, and then that becomes my alpha. Okay, so that identity there, we're going to replace it with 2 sine of a cos of a. Sorry, alpha will be our a. So that would be 2 sine, a is 3x, cos of 3x. And I have completed it. So basically what it's saying is, it's saying when you're done, a would have been replaced with 3x. And if you look, these a's here at the end of the day were replaced with 3x's. So we're going to do the same sort of thing. Given a double angle, write it as a double angle. So sounds a little bit confusing, but let's look at this. So it says write double angle identities for cos of 10a. They want me to write this as a double angle. To write this as a double angle, I need to have the cos of 2 times alpha. So rewriting this as a double angle, it would be cosine 2. And now I have to figure out what my alpha is. If I divide 10a by 2, I get 5a. I've just rewritten this as a double angle. Now I'm going to use the identity. So I have 3 identities that I could choose from for cos, and I'm just going to use this first one. So this is equal to cos squared of a. And remember that, sorry, cos squared of alpha. Alpha would be this. So that would be cos squared of 5a minus the sine squared of 5a. Okay, so again, I just, what I did was I took the cos of 10a and I wrote it as a double angle identity. Double angle has to have a 2. All right, let's look at this one right here. So this one right here is going to be a little bit more complicated. It is going to be a homework question though, or you're going to need to understand how to do this for a homework question. They give me the tan of x. I know that this is the tan of 1x. In order to write this as a double angle identity, I need to get a 2 in front. So I need to have the tan, so my argument needs to have a 2 times the angle, which is alpha. So how do I do that if I have a 1? What you need to sort of realize is what we did in all these other examples. I had 10a. In order to get a 2, I divided 10a by 2, right? Over here, I had 6a. In order to turn it into a double angle, I divided it by 2. So we're going to do the exact same thing. I have a 1 here. I'm going to divide that 1 by 2. So that would be 1 over 2x, because this would equal tan of 1x. right? So we're always just taking the number in the argument and you're going to be dividing it by 2. And now I have the double angle, because the double angle is when I have that 2 there, and then my alpha is going to be this right here. Okay, what is that equal to? The identity for the tan, the double angle for tan, would be this. So it's 2 tan of alpha, which is 1/2 x, all over 1 minus tan squared of alpha, which is 1/2 x. And that is how you would do class example number 2. Okay, let's look at the last class example, which is class example number 3. So what it says is express each of the following terms into a single trig function. So if you look, this is not a single trig function. I've got sine and I've got cosine. What's going to happen when you start practicing and doing homework questions for your double angle, you will recognize that this is going to be a double angle. So you're going to match it up, right? And this is very close to this double angle here. So I'm going to match this with this form here. Okay, so where am I going to go from this? According to this form, it would be 2 sine of alpha cos of alpha. So I'm just going to identify 4x is going to be my alpha. And this, the identity for that, is the double angle for sine. So that would be the sine of 2 times alpha. Alpha is 4x. And then that could simplify to be the sine 2 times 4 is 8x. Okay, so that's exactly how we would do, sort of going in reverse. Given the right-hand side of the identity, how could you convert it to look to be the left-hand side? Okay, look at this one. Cos squared theta minus sine squared theta. And then it gives us an angle here. Be cautious with this one. This is not a plus. So it's not a Pythagorean identity. The Pythagorean identity would be this cos squared of theta plus the sine squared of theta is equal to 1. So because this is not a plus, it's actually going to be one of our double angle identities. If I look, it matches with this double angle identity here, cos squared of alpha minus sine squared of alpha. So I'm just going to right now identify 1/2 of a as my alpha. And I'm going to rewrite this using the form for the double angle of cos, and it would be this one here. So that's going to be the cos 2 times alpha. And what is alpha? Alpha is 1/2 a. Okay, let's simplify this, and that becomes the cos 2 over 2 would cancel, and it just becomes the cos of a. Let's look at this last question. And the last question is going to be, it's the most complex. So we will look at this. So it would be a standard of excellence question. When I look at this and I say, okay, I'm going to match this up to a double angle. It looks really close to this form here. But what it is missing a 2, right? So you have to see that it's missing a 2. So what I'm going to do, because I know it's going to go into this form here, and this is the identity that I'm going to use, I need to put a 2 in front of this. Now, what happens, so I'm just going to write that 2 in. So 2 sine, my alpha is 5 over 2x, cos 5 over 2x. You can't just, in math, take an expression and put a 2 in front of it, right? You have to balance that. I can't just pick 2 out of nowhere and put it in front of my expression. How would you balance that 2? There was originally a 1 here, right? So basically, how do I get this back to a 1? It would be multiplying by 1/2. Because if I multiply this expression by 1/2, what's going to happen is that becomes 1 again, right? But I need the 2 here in order to rewrite this as the identity for the sine of 2 alpha. So to do that, I cannot drop this 1/2, so I have to write that 1/2. And then I'm going to rewrite this as the identity of the sine of 2 times alpha. And alpha is going to be 5 over 2x. And then what's going to happen is 2 over 2 will cancel, and you'll have 1/2 sine of 5x. So the most common mistake that students make on diplomas, or if this is an exam question, is they know they have to add the 2, right, in order to use the double angle identity. And then they convert it to the form, which would be the sine of 2 alpha, the double angle for sine, and they forget to balance by adding the 1/2 and bringing down the 1/2. You will never drop the 1/2 for this question. And that is it. The last thing I just want to point out, this is one last question I have in your note package. So it is going to be a podcast 14D. It is a really good question that is often on diplomas, so you could watch that. And then here is going to be your homework for lesson 7. It'll be these questions here. What I want to point out is question 8 and 9 are the standard of excellence questions. If you have trouble with either 8 or 9, they are podcasted. So this question 8, if you go to the podcast for Trig 2, it's actually going to be diploma question 7. So if you open diploma question 7, you will see this question. And then if you have trouble or difficulty with question 9, open up the podcast for diploma question 8, and that's going to match this question. If you want any additional podcasts, there's 4 podcasts that you could watch, and 14D, I have that podcast was this one here, which is just a good important podcast to know for your diploma.